Lieutenant Takeshi Nakamura felt the cold seeping through his leather flight suit despite the sheepskin lining. At 22,000 feet above Rabaul, the temperature inside his Mitsubishi A6M0's cockpit had dropped to well below freezing. It was January 1943, and he was leading a patrol of 6 fighters tasked with intercepting American bombers reported heading toward the Japanese base. At this altitude, he believed his squadron was untouchable. The Zero could climb higher than any American fighter he had encountered. Intelligence briefings had confirmed this. Combat reports from China, from the Philippines, from the early months of the Pacific War, all supported the same conclusion. Japanese fighters owned the sky above 20,000 feet. American aircraft, heavy and built like trucks according to the prevailing wisdom, could not follow them into the thin air where Nakamura now flew. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. He scanned the sky below, looking for the dark specks that would indicate bombers. His oxygen mask pressed uncomfortably against his face, the rubber cold and stiff. The cockpit glass had frosted at the edges. His hands, even inside thick gloves, felt numb as he gripped the control stick. But these were acceptable discomforts. Height meant safety. Height meant advantage. Height meant he could dive on the enemy with the sun behind him, strike, and climb away before the lumbering American fighters could respond. Then he saw something that should not have been possible. High above him, perhaps 15,000 feet higher, white contrails were forming. Not one, but multiple parallel lines scratching across the blue-black sky at an altitude he had believed unreachable by American aircraft. The contrails were moving fast, far faster than bomber formations. These were fighters. Nakamura's first thought was that his eyes were deceiving him. That altitude sickness was affecting his perception. He had been trained to recognize the signs: confusion, impaired judgment, visual distortions. But when he looked again, the contrails were still there, still impossibly high, now beginning to turn in his direction. His squadron mates had seen them too. Radio chatter filled his headset, voices tight with confusion and the beginning of something else. Fear. The Americans were above them. The Americans, whose fighters were supposed to be too heavy and underpowered to climb above 18,000 feet, were flying at altitudes approaching 40,000 feet. And they were diving now, coming down with speed that no amount of Japanese training or fighting spirit could counter. The fundamental assumption of his training, the belief that had governed Japanese fighter tactics since the war began, was about to be shattered by the simple reality of watching enemy aircraft appear from above when nothing should have been there. Japanese naval aviation had built its doctrine on the concept of altitude supremacy through the 1930s. The philosophy was straightforward. A lighter aircraft with better climb rate could dictate the terms of engagement. Height provided energy. Energy provided speed. Speed provided the ability to attack or disengage at will. This was not mere theory. It had been proven in combat over China starting in 1937. The Mitsubishi A6M0, which entered service in 1940, represented the culmination of this design philosophy. Engineers at Mitsubishi, led by designer Jiro Horikoshi, had been given strict parameters. Create a fighter that could outclimb, outturn, and outrange any aircraft then flying. They succeeded by making compromises that seemed reasonable given the expected opposition. The Zero's empty weight was just 3,970 pounds. Compare this to American fighters being developed at the same time. The Grumman F-4F Wildcat weighed over 5,000 pounds empty. The weight savings came from everywhere. The Zero used no armor protection for the pilot. It had no self-sealing fuel tanks. Its structure was built to minimum strength requirements with no safety margins. Every pound saved translated to better performance. The result was extraordinary. The Zero could climb to 19,680 feet in 7 minutes and 27 seconds. Its service ceiling, the maximum altitude at which it could maintain controlled flight and maneuver, was 33,000 feet for the A6M2 model and 38,000 feet for later variants. In 1941 and 42, no Allied fighter in the Pacific could match these numbers. Japanese pilots who flew the Zero described it as responsive, almost alive in their hands. It could turn inside any enemy fighter, could climb away from danger, could extend its range to escort bombers on missions that American planners thought impossible. The Zero's combat radius was over 1,500 miles with drop tanks. It could loiter over a combat zone for extended periods. It could reach altitudes where enemy fighters gasped for air and lost performance. This superiority had been demonstrated repeatedly in combat. Over China, Japanese fighters routinely bounced Chinese-piloted aircraft from above. In the opening months of the Pacific War, Zeros flying from carriers destroyed Allied air forces across Southeast Asia and the Dutch East Indies, over the Philippines, over Malaya, over the Netherlands. East Indies, the pattern repeated. Japanese fighters climbed higher, positioned themselves advantageously, and dove on their opponents with devastating results. American and British pilots who survived encounters with Zeros filed reports emphasizing the aircraft's altitude performance. The Zero could climb above them, could chase them into the thin air where their engines lost power, could appear from above without. Warning. Allied intelligence assessed the Zero as the premier fighter in the Pacific theater, superior in almost every performance category to the fighters opposing it. Japanese military leadership internalized these successes. The Zero's dominance confirmed the wisdom of their design philosophy. Training manuals emphasized altitude tactics. New pilots were taught to climb before engaging, to maintain height advantage, to use superior climbing ability as both offensive weapon and defensive escape. The concept became doctrine. Height meant victory. The enemy could not reach you if you flew high enough. This belief, supported by 2 years of combat success, was about to encounter American engineering that approached the problem from an entirely different direction. The Americans had been watching Japanese fighter performance with growing concern since 1941. Intelligence reports and combat assessments painted a clear picture. Japanese fighters, particularly the Zero, had significant altitude advantages. American fighters struggled above 20,000 feet. Their engines lost power in thin air. Their climb rates fell off dramatically. Their pilots fought at a disadvantage whenever Japanese fighters controlled the high altitude. The United States Army Air Forces recognized this problem and had been working on a solution since before the war began. The answer was not to make lighter aircraft. American design philosophy went in the opposite direction. Build strong, build durable, protect the pilot, install heavy armament, then solve the engine power problem through technology. The technology was turbocharging. Turbocharging was not a new concept. The principle had been understood since the First World War. As aircraft climbed, air density decreased. Less dense air meant less oxygen in each engine cylinder. Less oxygen meant less combustion power. Less power meant declining performance at altitude. A turbocharger, driven by exhaust gases, compressed incoming air before it entered the engine cylinders. Compressed air had more oxygen. More oxygen meant the engine could maintain sea-level power even in thin air. The technical challenges were substantial. Turbochargers operated at extreme temperatures, often exceeding 1,700 degrees Fahrenheit in the turbine housing. They spun at enormous speeds, typically 50,000 to 70,000 revolutions per minute. They had to be precisely controlled to prevent overboost that could destroy an engine. They added weight and complexity. They required skilled maintenance, but they worked. General Electric had been developing aircraft turbochargers since the 1920s under the direction of engineer Sanford Moss. By the late 1930s, they had created reliable systems that could maintain engine power to altitudes exceeding 30,000 feet. The challenge was integrating these systems into combat aircraft. Fighters needed to be nimble and lightweight. Turbochargers were neither. Lockheed Aircraft Corporation found a solution in an unconventional design. The P-38 Lightning, which first flew in January 1939, was a twin-engine, twin-boom fighter with the cockpit and armament housed in a central nacelle. The configuration allowed placement of turbocharged Allison V-1710 engines in each boom with adequate space for the turbocharger installations and intercooler systems. Each Allison engine produced 1,475 horsepower at war emergency power settings. The turbochargers allowed the engines to maintain this power to altitudes where normally aspirated engines would be producing half that output or less. The P-38's service ceiling was officially listed as 44,000 feet. In practice, pilots reported maintaining controlled flight above 40,000 feet routinely. The aircraft that resulted was unlike anything Japanese pilots had encountered. The P-38 weighed 17,500 pounds fully loaded for combat, more than double the Zero's combat weight. It carried 4 50-caliber machine guns and one 20-millimeter cannon, all mounted in the nose for devastating concentrated firepower. It had armor protecting the pilot. It had self-sealing fuel tanks. It had redundancy with 2 engines, and crucially, it could climb to 30,000 feet in under 13 minutes and continue climbing to altitudes where Japanese fighters could not effectively maneuver. At 35,000 feet, a Zero was near its operational ceiling, struggling to maintain altitude and speed. At 35,000 feet, a P-38 was still climbing with power and control to spare. The performance gap at extreme altitude was even more pronounced. At 40,000 feet, a P-38 could still fight. A Zero at 40,000 feet, if it could reach that height at all, would be wallowing, barely controllable, its engine gasping in air so thin that combustion became unreliable. American pilots trained in P-38s learned to exploit this advantage systematically. Climb above the enemy. Use superior altitude to dictate engagement terms. Dive with speed advantage. Strike with overwhelming firepower. Extend and climb away if the enemy attempts pursuit. The enemy cannot follow you into thin air. It was the same tactical philosophy Japanese pilots had used successfully for years, but now turned against them by aircraft that could reach altitudes they had believed were their exclusive domain. The P-38 that arrived in the Southwest Pacific Theater in late 1942 was the P-38F model, followed by the improved G and H variants through 1943. Each represented refinements to the basic design, but all shared the fundamental advantage: turbocharged engines that maintained power at extreme altitude. Understanding how this worked required understanding the complexity American engineers had mastered. The Allison V-1710 engine was a liquid-cooled 12-cylinder design producing 1,150 horsepower at normal rated power. With the turbocharger engaged and properly controlled, that figure increased to 1,475 horsepower at war emergency power. The turbocharger itself was a General Electric Type B2 unit mounted in each engine nacelle behind the engine. Exhaust gases from the engine flowed into the turbine wheel, spinning it at speeds exceeding 60,000 revolutions per minute. This turbine drove a compressor wheel that pressurized incoming air. The compressed air, now hot from compression, passed through an intercooler that used ram air to reduce its temperature. Cooler air was denser, providing more oxygen for combustion. The cooled, compressed air then fed into the engine's supercharger, which provided additional compression before the air entered the cylinders. The system required precise control. A regulator adjusted the amount of exhaust gas flowing through the turbine, maintaining desired manifold pressure as altitude changed. Too much boost could destroy an engine through detonation. Too little meant wasted performance. Pilots had to monitor manifold pressure gauges, cylinder head temperature, and oil temperature constantly. They had to adjust mixture controls, propeller pitch, and throttle settings in coordination with turbocharger operation. American pilots received extensive training on these systems. At training bases like Williams Field in Arizona and Luke Field in Phoenix, P-38 students spent hours in ground school learning turbocharger theory and operation. They practiced emergency procedures for turbocharger failures. They learned to recognize the symptoms of overboost and how to prevent damage. They flew training missions specifically focused on high-altitude operations, climbing to 30,000 feet and above to experience the environment where they would fight. The oxygen systems were equally sophisticated. P-38 pilots breathed pure oxygen through Type A-14 demand oxygen masks connected to liquid oxygen converters that turned cryogenic liquid oxygen into breathable gas. The system could supply oxygen continuously at altitudes up to 40,000 feet. Pilots were trained to check their oxygen systems before every high-altitude mission, to recognize symptoms of hypoxia, and to descend immediately if oxygen supply was interrupted. At altitudes above 30,000 feet, the environment was hostile in ways ground-bound humans rarely experienced. The temperature at 40,000 feet was typically minus 60 degrees Fahrenheit, or colder. The air pressure was less than 3 pounds per square inch compared to 14.7 pounds per square inch at sea level. Without pressurization, a human could not survive more than a few minutes. The P-38 cockpit was not pressurized. Pilots relied entirely on their oxygen systems and heavy flight clothing. They wore leather flight suits lined with sheepskin or wool. They wore electrically heated gloves and boots connected to the aircraft's electrical system. They wore leather helmets with integrated oxygen masks and communication equipment. Despite all this equipment, pilots still suffered from extreme cold during long, high-altitude missions. Frostbite was a constant risk. Men returned from missions with frozen fingers and toes despite heated gear. But they could fight at these altitudes. Japanese pilots could not effectively. The Zero had no turbocharger. Its Nakajima Sakai 14-cylinder radial engine was normally aspirated with a single-stage 2-speed supercharger. This provided adequate power at low and medium altitudes, but performance fell off dramatically above 25,000 feet. The engine produced 1,130 horsepower at takeoff power at sea level. At 30,000 feet, it was producing perhaps half that. Japanese pilots had oxygen systems, but they were primitive compared to American equipment. Early war Japanese oxygen systems used compressed oxygen stored in bottles, regulated through simple valves. The masks were uncomfortable and leaked. Pilots frequently removed them to communicate or to relieve discomfort, risking hypoxia. Training on oxygen use was minimal. Many Japanese pilots did not fully understand the dangers of high-altitude flight without adequate oxygen. The tactical implications were profound. When P-38s climbed to 35,000 feet or higher, they entered an operational environment where Japanese fighters could not effectively challenge them. A Zero attempting to reach 35,000 feet would take an extended time to climb, consuming fuel and leaving the pilot exhausted from breathing thin air. Once there, the Zero would have minimal performance. Its controls would be mushy. Its engine would be struggling. Its climb rate would be measured in feet per minute rather than hundreds of feet per minute. Meanwhile, the P-38 at the same altitude retained substantial performance. It could still climb at several hundred feet per minute. Its controls remained responsive. Its engines delivered power. Most importantly, it could dive from this altitude with tremendous speed, strike targets below, and climb back up before Japanese fighters could respond. The energy advantage was insurmountable. The 5th Air Force, operating in the Southwest Pacific under General George Kenney's command, began receiving P-38s in numbers during late 1942 and early 1943. The 49th Fighter Group and the 38th Fighter Group converted to P-38s from P-40 Warhawks. These units would pioneer high-altitude fighter tactics against Japanese forces. Squadron commanders quickly recognized the P-38's altitude advantage. Standard operating procedures emphasized climbing to maximum altitude before engaging enemy formations. Fighter sweeps would typically launch with instructions to climb to 30,000 feet or higher while proceeding toward target areas. Bomber escort missions had P-38s flying several thousand feet above the bomber formations, positioned to intercept any Japanese fighters attempting to dive on the bombers. The doctrine was methodical. P-38 formations would orbit at altitude, watching for Japanese fighters below or climbing toward them. When Japanese fighters appeared, P-38 pilots would maintain altitude advantage, waiting for the optimal moment to attack. If Japanese fighters climbed toward them, P-38 pilots would simply climb higher, maintaining separation. Japanese fighters, struggling at extreme altitude with engines losing power, could not catch them. When the moment came to attack, P-38 pilots dove with devastating speed. At 35,000 feet, the P-38 already had significant potential energy from altitude. Diving added kinetic energy. Pilots could reach speeds exceeding 400 miles per hour in a dive, sometimes approaching the aircraft's compressibility limits. They would plunge through Japanese formations, firing their concentrated nose armament, then extend away at high speed and climb back to altitude. Japanese pilots attempting to follow the diving P-38s found themselves unable to keep up. The P-38's higher weight and more powerful engines gave it better diving acceleration. Japanese pilots would watch P-38s disappear below them, strike targets, then reappear above them minutes later, having outclimbed them back to high altitude. The frustration was maddening. Intelligence reports from captured Japanese pilots revealed the psychological impact. They described feeling helpless against an enemy who could appear from above without warning, attack at will, and escape before effective counteraction was possible. The altitude sanctuary they had relied on for years no longer existed. American fighters had taken it from them through superior engineering. The operations over Rabaul beginning in October 1943 demonstrated this advantage systematically. Rabaul, located on New Britain Island, was a major Japanese base with extensive air defenses and large numbers of fighters. American forces planned to neutralize Rabaul through sustained air attacks, destroying Japanese air power and isolating the base. P-38 units flew fighter sweeps and bomber escort missions over Rabaul repeatedly from October through early 1944. Japanese defenders, including elite units with experienced pilots, scrambled to intercept these raids. The pattern that emerged was consistent. Japanese fighters would climb to intercept, typically reaching 20 to 25,000 feet. P-38 escorts would be at 30 to 35,000 feet, sometimes higher. When Japanese fighters attempted to climb higher to reach the P-38s, they found their aircraft struggling. The climb rate dropped to barely sustainable levels. The controls became heavy and unresponsive. The engines ran rough in the thin air. Meanwhile, the P-38s above them maintained formation effortlessly, their turbocharged engines delivering power that Japanese fighters simply could not match. Some Japanese pilots, the most skilled and determined, managed to reach altitudes approaching 35,000 feet in attempts to engage the P-38s. These pilots were flying at the absolute limit of their aircraft's capability and their own endurance. They described the experience in post-war interviews and interrogation reports. The cold was intense despite heavy clothing. The lack of oxygen caused lightheadedness and impaired judgment even with oxygen masks. The aircraft felt sluggish, responding slowly to control inputs. And still the P-38s were above them. The American fighters would climb higher if Japanese fighters approached too closely, or they would dive, using their speed and firepower advantage to devastate the Japanese formation, then climb away before the disoriented Japanese pilots could react. There was no counter-tactic that worked. No amount of courage or skill could overcome the fundamental performance disadvantage. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The statistics told the story. In the air battles over Rabaul from October 1943 through February 1944, Japanese air units suffered catastrophic losses. Hundreds of aircraft were destroyed. Experienced pilots were killed faster than they could be replaced. The 5th Air Force, led by P-38 units, achieved air superiority through a combination of numbers, better aircraft, and tactics that exploited altitude advantage systematically. On a clear morning in November 1943, Lieutenant Saburo Sakai, one of Japan's highest-scoring aces with over 60 confirmed victories, led his flight of Zeros from Rabaul to intercept reported American bombers. Sakai had survived years of combat. He had been wounded over Guadalcanal, losing vision in his right eye from a gunner's bullet that struck his head. He had recovered and returned to combat duty. He understood air fighting better than most men in the Japanese Navy. His flight climbed toward the reported bombers, reaching 23,000 feet. They spotted the American formation. B-24 Liberators flying in a defensive box formation, protected by fighters. Sakai looked for the escort fighters, expecting to see them at similar altitude or slightly above the bombers. Instead, he saw contrails high overhead at least 10,000 feet above his position. The contrails were distinctive, twin parallel lines indicating twin-engine aircraft. P-38s. Sakai knew these aircraft by reputation. They were fast, heavily armed, and dangerous. But seeing them so far above his position shocked him. His own aircraft was already struggling at 23,000 feet. The controls felt heavy. The engine was running rough, and the Americans were another 2 miles higher in the sky. He made the decision to climb to try to reach an altitude where he could challenge the escorts. His flight followed him upward. The climb was agonizing. At 25,000 feet, his Zero was barely maintaining altitude. The rate of climb had dropped to a few hundred feet per minute. At 28,000 feet, he was gasping for breath despite his oxygen mask. The cold had seeped through his flight suit. His hands were numb. At 30,000 feet, approximately his aircraft's service ceiling, he leveled off. The P-38s were still 5,000 feet above him, circling leisurely. He watched them, looking for any sign they would descend to fight. Instead, they maintained altitude, clearly visible against the dark blue sky, white contrails marking their every turn. Then they dove. Not just 1 or 2 aircraft, but the entire formation, 8 P-38s in a coordinated diving attack. They came down with incredible speed, their twin engines howling, their distinctive twin-boom silhouettes growing rapidly larger. Sakai shouted warnings to his flight, but coordination at this altitude was nearly impossible. The radio quality was poor. His pilots were scattered, each struggling with their own aircraft at extreme altitude. The P-38s flashed through the Japanese formation at over 400 miles per hour. Their nose-mounted guns, 4 50-caliber machine guns, and 1 20-millimeter cannon per aircraft, concentrated devastating firepower. 1 Zero exploded immediately, struck by multiple cannon rounds. Another fell away trailing smoke, its engine destroyed. A third spun downward, Its pilot slumped in the cockpit, killed by machine gun fire. Sakai rolled his Zero, attempting to evade, but the aircraft responded sluggishly at this altitude. A P-38 swept past him, so close he could see the American pilot's face behind the cockpit glass. Tracers streaked past his canopy. Then the P-38 was gone, extending away at a speed Sakai's Zero could not match, beginning to climb again. He tried to follow, diving to gain speed, but it was futile. By the time his Zero had accelerated, the P-38s were already climbing back to altitude, their powerful engines pulling them upward effortlessly. Within minutes, they were at 35,000 feet again, reforming their defensive pattern above the bombers. Sakai's flight was scattered, reduced from 6 aircraft to 3. The survivors were low on fuel from the extended high-altitude maneuvering and had no choice but to break off and return to base. The experience was repeated across the Pacific Theater wherever P-38s deployed. At Wewak, New Guinea, Japanese fighters attempting to defend their airfield faced P-38s attacking from altitudes they could not reach. Over the Philippines in late 1944, Japanese pilots scrambled to intercept American bombing raids only to find P-38 escorts waiting at 40,000 feet, invisible to Japanese pilots straining at 30,000 feet. Japanese aviation commanders recognized the problem almost immediately. Intelligence reports from surviving pilots painted a consistent picture. American fighters were operating at altitudes Japanese aircraft could not effectively reach. The tactical advantage Japanese pilots had relied upon since the war began had been reversed through American engineering. The question was what to do about it. The immediate response was tactical adaptation. Fighter units received new instructions emphasizing different engagement approaches. If altitude advantage was impossible to achieve, pilots should engage at lower altitudes where their aircraft maintained better performance. They should avoid climbing to meet high-altitude American formations. They should wait for opportunities when American aircraft descended to attack ground targets, or when weather conditions prevented high-altitude operations. These tactical changes helped somewhat, but could not overcome the fundamental problem. American bombers, escorted by P-38s at extreme altitude, could strike targets with relative impunity. Japanese fighters attempting to intercept the bombers had to climb through layers of P-38 escorts positioned at various altitudes. The Americans had created a defensive system that exploited their altitude advantage systematically. Japanese engineers and military planners understood that the real solution required new aircraft with performance matching or exceeding American fighters at high altitude. Design work began on several advanced fighters incorporating features intended to improve high-altitude capability. The most notable was the Kawanishi N1KJ Shiden, known to Americans as George, and the Mitsubishi J2M Raiden, called Jack. These aircraft featured more powerful engines, better supercharging systems, and structural improvements to handle high-altitude operations. The Raiden, in particular, was designed specifically as a high-altitude interceptor with emphasis on climb rate and altitude performance. Its Mitsubishi Kase 23 engine produced 1,800 horsepower and used a 2-stage supercharger to maintain power at altitude, but these aircraft arrived too late and in too few numbers to change the strategic situation. The Raiden entered service in late 1943, but production was limited by Japan's strained industrial capacity and persistent technical problems with the engine. Only 476 were built during the entire war. The Shiden suffered similar production constraints. These advanced fighters were distributed in small numbers to units defending critical areas, primarily the home islands, rather than being deployed broadly across the Pacific Theater. Meanwhile, American P-38 production continued at overwhelming scale. Lockheed's Burbank, California facility produced over 9,800 P-38s during the war. When combined with production at Lockheed's Dallas facility, total P-38 production exceeded 10,000 aircraft, and this was just one American fighter type. Republic P-47 Thunderbolts, also equipped with turbochargers and capable of similar high-altitude performance, were produced in even greater numbers, over 15,000 aircraft. The industrial disparity was crushing. Japan's entire aircraft production in 1943 totaled approximately 16,000 aircraft of all types: fighters, bombers, reconnaissance planes, transports. The United States produced over 85,000 aircraft that same year. The ratio was more than 5-to-1, and the American advantage was growing as more factories came online and production efficiency improved. For Japanese pilots still flying Zeros and other earlier generation fighters, the knowledge that better aircraft existed but were not available to them added psychological strain to an already desperate situation. They knew they were fighting with obsolete equipment. They knew their opponents had overwhelming numerical and technological advantages. They knew survival was becoming increasingly unlikely with each mission. Training standards, which had been extraordinarily high in the early war years, deteriorated as experienced pilots were killed and replaced with hastily trained novices. New pilots arriving at operational units in late 1943 and 1944 had perhaps 100 flight hours compared to 300 to 600 hours for pilots who had fought in the war's early campaigns. These inexperienced pilots flying obsolete aircraft faced American pilots with better training, better equipment, and growing combat experience. The psychological impact manifested in various ways. Some pilots became fatalistic, accepting that death was inevitable, and focusing on taking as many Americans with them as possible. Others became cautious, avoiding combat when possible, trying to preserve their lives and their aircraft for the final defense of Japan. Unit cohesion suffered. The confident, aggressive fighter pilots who had dominated Pacific skies in 1942 were being replaced by exhausted, demoralized survivors and untested replacements. Combat reports from late-war Japanese pilots reflected this psychological deterioration. They described feeling helpless against American formations. They described watching friends die in unequal battles. They described the frustration of seeing enemy aircraft beyond their reach, knowing those aircraft could attack at will while they could only endure. The altitude advantage P-38s held over Japanese fighters was part of a larger pattern defining the Pacific War's progression. At every level, American material superiority overwhelmed Japanese capability. Where Japan could produce hundreds of aircraft, America produced thousands. Where Japanese training programs turned out pilots after abbreviated courses, American programs maintained high standards because they had the time and resources to do so properly. Where Japanese logistics struggled to supply forward bases, American logistics delivered overwhelming quantities of fuel, ammunition, spare parts, and replacement aircraft. The P-38's turbocharger system exemplified American industrial and technological sophistication. General Electric had invested decades in turbocharger development, supported by government funding and corporate resources. The manufacturing facilities producing turbochargers were themselves marvels of precision engineering, capable of producing components to tolerances measured in thousandths of an inch. The supply chain delivering raw materials to factories and finished turbochargers to aircraft assembly plants functioned with remarkable efficiency. Japan had nothing comparable. Japanese industry lacked the precision manufacturing capability to produce reliable turbochargers at scale. The few attempts to develop turbocharged aircraft engines encountered persistent technical problems. Engineers understood the theory but lacked the practical manufacturing experience to translate theory into reliable hardware. Resources that might have funded such development were allocated to more immediate needs: building more conventional aircraft, producing ammunition, constructing defenses. The educational and industrial infrastructure supporting American aviation development was generations ahead of Japanese equivalents. American universities graduated thousands of engineers trained in aeronautics, thermodynamics, metallurgy, and related fields. American corporations employed teams of specialists who could solve complex engineering problems. American test facilities could evaluate designs thoroughly before committing to production. American factories had skilled workers, modern machine tools, and effective management systems. Japan had talented engineers and dedicated workers, but they operated within a system that could not match American scale or sophistication. Universities produced far fewer engineers. Corporations had smaller research teams with limited resources. Test facilities were less extensive. Factories relied more on skilled craftsmen than on automated production systems. The entire industrial ecology was smaller and less capable. These differences manifested in countless ways beyond just fighter performance. American pilots flew aircraft with sophisticated radios that allowed coordinated tactics. Japanese pilots often flew with no radio or with unreliable equipment. American aircraft had robust electrical systems powering gun sights, heated flight suits, and instrument panels. Japanese aircraft had simpler electrical systems that frequently failed. American maintenance operations had abundant spare parts and trained technicians. Japanese maintenance crews improvised repairs with salvaged components. The accumulated effect of these advantages was decisive. By mid-1944, American forces had established air superiority across most of the Pacific theater. Japanese aircraft were being destroyed faster than they could be replaced. Experienced pilots were dying. Training programs could not maintain quality while increasing output. Supply lines were collapsing under submarine interdiction. The industrial base was being bombed. The battles over Rabaul, where P-38s demonstrated their altitude advantage so dramatically, were part of a campaign that destroyed Japanese air power in the region. By early 1944, Rabaul was isolated and neutralized without requiring a costly invasion. Japanese forces remained there, surrounded and cut off, while American forces advanced past them toward the Philippines and eventually Japan itself. Similar patterns played out across the Pacific. At Truk, once Japan's most important forward naval base, American carrier raids in February 1944 destroyed over 200 aircraft and numerous ships. Japanese fighters attempting to defend the base were overwhelmed by superior numbers and superior aircraft. Over the Marianas in June 1944, the Great Marianas Turkey Shoot saw Japanese carrier aircraft destroyed in massive numbers by American fighters that included P-38 units flying from recently captured bases. The altitude advantage was just one element in this comprehensive superiority, but it was symbolically important. The Zero had represented Japanese aerial dominance in the war's early phase. Its ability to climb above enemy fighters and dictate engagement terms had seemed to validate Japanese design philosophy and fighting spirit. When American fighters appeared above Japanese formations, operating casually at altitudes Japanese aircraft could barely reach, it shattered the psychological foundation of Japanese air combat doctrine. Japanese pilots who survived the war spoke in interviews and memoirs about the moment they realized they could not win. For some, it came when they saw P-38s circling above them in air they thought was theirs alone. For others, it came when they watched American bombers proceed to their targets, escorted by fighters flying so high they could not be intercepted. For all of them, it was a moment of recognizing that material reality trumped courage, training, and determination. The Americans had built better machines, and had built them in overwhelming quantities. No amount of fighting spirit could overcome that advantage. In the decades after the war, aviation, historians and engineers studied the Pacific Air War extensively, analyzing the factors that led to American victory and Japanese defeat. The altitude performance gap between P-38s and Japanese fighters became a case study in the importance of technological development and industrial capacity in modern warfare. The lessons learned influenced post-war aircraft design and military doctrine worldwide. American engineers who had worked on turbocharged engines during the war went on to develop jet engines and rocket propulsion systems. The expertise gained in high-altitude engine performance translated directly to the challenges of supersonic flight and space exploration. General Electric, which had produced turbochargers for P-38s and other aircraft, became a leading jet engine manufacturer. The institutional knowledge and manufacturing capability built during the war provided foundation for continued innovation. Japanese aviation, devastated by defeat, had to rebuild entirely. The occupation authorities dismantled Japan's military aviation industry. Aircraft factories were converted to civilian production or demolished. Engineers dispersed to other industries or left the country. It would be years before Japan could again design and build advanced aircraft, and when that capability returned, it was often in collaboration with American companies who had defeated them. For the pilots who had flown P-38s in combat, the aircraft remained a source of pride and strong memories. Veterans' reunions brought together men who had flown the distinctive twin-boom fighters over New Guinea, the Philippines, and eventually over Japan itself. They remembered the reliability of those Allison engines, the steady climb to altitude where Japanese fighters could not reach them, the confidence that came from knowing their aircraft could outperform anything the enemy flew. Some American pilots encountered their former opponents years later at international aviation gatherings or through veteran exchange programs. These meetings were often emotional, marked by mutual respect between men who had tried to kill each other decades earlier. Japanese pilots acknowledged the technical superiority of American aircraft. American pilots acknowledged the courage of Japanese pilots who continued fighting despite overwhelming disadvantages. Saburo Sakai, the ace who had watched P-38s circle above him at unreachable altitude over Rabaul, survived the war. He wrote memoirs describing his experiences, including detailed accounts of fighting against American aircraft with superior performance. He acknowledged that by 1943, he knew Japan could not win the war. The evidence was too clear. American aircraft, American pilots, American industrial might were too superior. But he continued fighting because that was his duty, and because he hoped to protect Japan from invasion. Sakai lived until 2001, dying at age 84. His later years, he traveled to the United States multiple times, meeting with American veterans and speaking at aviation events. He described the P-38 as one of the most formidable aircraft he faced, particularly because of its altitude performance. He said that seeing those twin-engine fighters circling high above, knowing they could attack whenever they chose while he could not reach them, was one of the most frustrating and demoralizing experiences of his combat career. The morning Lieutenant Takeshi Nakamura had looked up and seen contrails impossibly high above him represented more than just a tactical surprise. It represented the moment when Japanese air power's fundamental assumptions collided with American technological reality. The belief that Japanese fighters owned the high altitude, that lighter aircraft with better climb rates controlled the sky, that fighting spirit could overcome material disadvantages. All these assumptions were shattered by the simple fact of American fighters flying higher, faster, and more effectively than Japanese doctrine said was possible. The war continued for another 2 years after that moment, but the trajectory was set. American aircraft would dominate Pacific skies through superior performance and overwhelming numbers. Japanese pilots would continue fighting with courage and skill, but they would fight at disadvantage that grew more pronounced with each passing month. The altitude gap was just one measure of a broader disparity that encompassed every aspect of industrial warfare. In the end, The story of P-38s appearing at 38,000 feet above Japanese fighters expecting to control the sky at 20,000 feet was a story about what happens when different industrial systems collide. One system had invested in technology, infrastructure, and mass production. The other had prioritized lighter, simpler designs, optimized for the last war rather than the current one. One system could afford to build heavy, complex aircraft with expensive turbochargers and sophisticated systems because it had the industrial base to support that approach. The other could not. The Japanese pilots who looked up that morning and saw American fighters where nothing should have been were witnessing the physical manifestation of industrial disparity. They were seeing the proof that their training, their courage, and their skill could not overcome the simple reality that the enemy had better machines. The contrails etching across the sky miles above them were writing Japan's defeat in vapor trails that stretched from horizon to horizon. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.